counting principles. A basic counting rule states that if we're asked to choose one item from each of two separate and there are M items in each category, the first category, and N items in the second category, then the total number of choices is given by M times N. This is sometimes called the multiplication rule for probabilities. All right, for example 1, there are 21 novels and 18 volumes in poetry on a reading list for a college English course. How many different ways can a student select one novel and one volume of poetry to read during the semester? So we're going to multiply our options. How many options are there for novels? There are 21 novels. Times how many poetries? 18. So multiplied, that's 378 different possible combinations. All right, example 2. Jonathan owns 6 pairs of pants, 12 shirts, and 3 pairs of shoes. How many different outfits can he make if he chooses one of each? So he's going to choose 1 of 6 pants times 1 of 12 shirts times 1 of the 3 pairs of shoes. So the possible outfit combination is 216 outfits to choose from. Example 3, a multiple choice test has 8 questions. If there are 4 answer choices for each question, how many different ways can the test be completed? Well, we're going to kind of just draw a chart. There's question number 1, question number 2, question number 3, question number 4, question number 5, question number 6, question number 7, and question number 8. All right, I've got 8 spots because I've got 8 questions. How many answer possibilities are there for the first question? 4 answer choices. How many options for number 2, for number 3, number 4, number 5, number 6, number 7, number 8. So lots of possibilities here, but if you have 8 questions, 4 choices each, that ends up being 4 to the 8th, which is 65,536. A lot of possibilities. We're going to next go look at a permutation. A permutation is an important mathematical operation for counting. We are introducing here what's called n factorial. So when we have the little exclamation mark, that is our mark for a factorial. What a factorial is we're going to take the number and we're going to multiply by that number minus 1, minus 2, up to the very last one. So for example, we're going to do 5 factorial. That means we're going to multiply 5 times 5 minus 1, which is 4, and then we just go down 3, 2, and we stop at 1. All right. So 5 factorial is 5 times 4 times 3 times 2 times 1. That ends up being 120. Let's go catch another quick example. 7 factorial, we're going to take 7, and we're going to multiply down to 1. So 7 times 6 times 5 times 4 times 3 times 2 times 1. It's quite a bit bigger. It's 5,040. So a factorial multiplies down to 1. In situations where counting is involved, one must determine whether the order matters or not. When the order matters, we use a permutation. All right, we say in this case there are n we have NPR, so we have permutations of size r. There are n permutations of size r as we're looking through it. And this is where order matters. It turns out we can express this result as factorials. So if we have NPR, then it's going to end up being n factorial over n minus r factorial. We're going to go get a quick example before we get to our next one. So if we have 10, pick 3, then that's going to become 10 factorial over 10 minus 3 factorial. So 10 factorial over 7 factorial. Now this is the only time I'm going to write it all the way out. Below I'm going to do what I call like an easier or quicker version, but just in this first one I'm going to write it all the way out. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Takes a little bit to write all of that. Let me try drawing that again. All right, 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, now we could multiply all that out. It's going to get really big. Instead, what we want to do is to go ahead and cancel. Notice we could say, oh, they have 7s and 6s and 5s and 4s and 3s and 2s and 1s. So basically, we canceled all of these 7 down to 1, 7 factorials from each. This left 10 times 9 times 8, 10 times 9, 9 times 8. This gives us 720. All right, now that was kind of what I'm going to call the longer route. Let me show you the easier route. We have the 10 factorial over 7 factorial. And as we saw in the above example, when we got to the 7s, they started canceling. So I'm just going to go 10 times 9 times 8, and then I'm going to stop at the 7 factorial because I realized that I have a 7 factorial in the denominator. So that means the 7, 6, 5, 4, 3, 2s, and 1s would cancel. And canceling the 7 factorial, that leaves 10 times 9 times 8, which is 720. Let's go get an example. How many different ways can the letters of the words math be arranged to form a 4-letter code word? All right, so we have a 4-letter code word. So here's a spot for our 4 letters. We are taking the word math and working with it. How many letters are in the word math? 4. So we have 4 choices for the first letter. How many choices are going to be left for the next letter? Only 3 because we already used the letter. All right. And then if we've used 2 letters, that leaves 2 and then 1. So kind of going through and like if there's 4 letters available, I pick 1 from 4, and then that leaves 3 to pick 1 from the next letter, 2 to pick 1 from the next letter, and then the last letter just has to be whatever's left. All right, so 4 times 3 times 2 times 1 is 24. So there's 24 ways we could arrange the letters M, A, T, and H. Now, we could also use this as like from 4 letters, we're picking 4. So using our formula, that would be 4 factorial over 4 minus 4 factorial. So this would be 4 times 3 times 2 times 1. And we do have a rule that the 0 factorial is actually 1, giving us the 24. Either of those are valid ways to find an answer for that question. In our next example, 80 sprinters have made it to the Olympic finals in the 100-meter race. How many different ways could gold, silver, bronze be awarded? Now, this is being awarded without any impact on like how fast they are or anything like that. Just saying, hey, if we have 80 people, how could we arrange them gold, silver, bronze? So we have a spot for gold, and we have a spot for silver, and we have a spot for bronze. All right, now, of the 80 sprinters, one of those 80 can get first place. But then once first place is given out, there's no longer 80 available to get second because someone got gold or got first. So that would leave 79 to select from for second place. And then again, once first and second have been awarded, then that moves us down to only 78 people being available for bronze. So multiplying that out, we would get 492,960. On the other side, if we wanted to do it with a 80 pick 3, because from 80, pick 3, we would then have 80 factorial over 80 minus 3 factorial. That gives us 80 factorial over 77 factorial. Now, I don't know about you, but I really don't want to write 80 times 79 times 78 all the way down to 1. So what we're going to do is I'm going to do 80 times 79 times 78, and then I'm going to stop at the 77 and put a factorial on it, because what do we see sitting in the denominator? That's 77 factorial. So that way we can cancel the 77 factorials. That would still leave the 80 times 79 times 78. which is 492,960. All right, last example for our video here. How many 4-character passwords can be made using the letters E, F, G, H, I, and J? So we have these letters to pick from. How many letters is that? 1, 2, 3, 4, 5, 6. All right, we've got 6 letters to choose from. Question A, if repeats are allowed, we are making 4-character passwords. So 1, 2, 3, 4 characters. Repeats are allowed, so we can choose from one of the 6 letters. Because repeats are allowed, we still have 6 to pick from, and 6 to pick from, and 6 to pick from, giving us 1,296. If repeats are not allowed, then when we pick for the 4-letter password, we have 6 on the first pick, but because repeats aren't allowed, then that leaves only 5 for the second pick, 4 for the third pick, and 3 for the last pick, which makes only 360 combinations. So allowing for repeats definitely gives more possibilities. If each password starts with the letter F, how many possibilities? So I'm still going to go ahead and draw my 4 spots for my 4-character password, but this time we know the first one is locked in at an F. And in fact, so then when we go through, we're going to say how many options are there for the second choice. Well, I'm going to go ahead and put in parentheses here because it doesn't say it. We're going to go ahead and run with the idea that repeats are allowed. So using repeats are allowed, that'd be 6 options for the second letter, 6 options for the third, and 6 options for the fourth choice, giving us 216. So if the first letter is an F and if repeats are allowed, there's still 216 possible combinations. What about if the third letter has to be a vowel? So this letter has to be a vowel. How many vowels do we have to choose from? Well, vowels are A, E, I, O, U. So we have E as a vowel and I as a vowel. We have 2 vowels in our selection to pick from. So there are 2 possible choices for that third letter. That third letter could be an E or an I. What about the first letter? Well, we have no restrictions, so we have 6 to choose from. Again, kind of operating with the fact that this is repeats allowed, so we would still have 6 to choose from. But the third letter has only 2 options. It has to be the vowels E or I, and then the last letter could be any of the 6, and that gives us 432 different possibilities.